Hello, we are Research IT. I'm Hannah.
And I'm Alana.
And together we create software resources and tools to enhance Agua Clara research.
Our goal as Research IT is to create IT resources to support Agua Clara research. We accomplish this by writing a Python package of code that's useful to research in Agua Clara. We promote skill development of computer science skills among the research subteams, and we encourage transparency of the research team's processes and results in their reports. By using common software tools, the research teams ensure that their calculations are efficient, accurate, and consistent. Well-organized documentation also preserves the information for future and other research teams.
As stated, one of our goals is to write a package of code useful to research subteams. This means writing a library of functions that will help them perform scientific calculations, such as physical, chemical, and hydraulic calculations, design their experiments, so calculate parameters relevant to modeling water treatment plants, as well as analyze their data. One of the modules, the code that we write is presented to research subteams in the form of a Python package that is publicly available and can be installed. This package includes 3 sub-packages, and our functions that we write for research subteams are found in the research package. There's also the design sub-package, which is written by and for the Agua Clara Infrastructure Design Engine team, AID, as well as the core package, which is used by both other packages and contains fundamental physical constants and functions. So one of the modules in this package is ProtoParser, which is actually being used by teams currently in their reports. This module contains functions that allow researchers to extract the data output by their data acquisition program, ProCoda, extract that data into Python arrays, which are easy to analyze and graph in Python. They can do this for data from a specific time to an ending time, as you see in this example. And for multiple columns of data, they can also do this over multiple days of the experiment and for specific states of data acquisition, which allows teams to move away from Excel and away from modifying their raw data to just do it all in Python.
Flock model models chemicals and other materials at the particle level. Flock model contains predefined materials that you can use to model the size of clusters that clay and coagulant tends to form. You can also define your own materials. This semester, we have been working on fixing multiple bugs found in that code. These bugs existed mainly because the module was completely untested previously. We fixed the functions involved in the bugs, but next semester, we will need to check that the rest of the functions are correct in how they model flocks and how they execute, and then complete testing for all the functions. We also worked on writing and testing the air density function in PhysChem. This function takes in pressure of the air in the system, the molar mass of the air in the system, and the temperature of the air in the system, and returns the density of the air. The air density used to be a constant, but now it's a function of pressure, temperature, and molar mass. We've been working on writing functions in the Peristaltic Pump module. The Peristaltic Pump module calculates the pump flow rates for equipment used by Agua Clara research teams. The vol per rev 3-stop function calculates the volume of fluid pumped per revolution by our specified pump through 3-stop tubing. 3-stop tubing is marked by 3 colored tags, and these colors are used to look up the particular tubing specifications.
Another module added to the Agua Clara research package this semester is Stock QC. And this module uses Python objects, which we'll explain, to perform mass balances on experimental reactors. So in themselves, mass balances are rather simple, but in a reactor, there may be many known parameters and several unknown, and creating a module that binds together this information into an object and into several functions allows researchers to do the same calculations, but much less redundantly, much more concisely, and more reliably.
We support CS skill development in research subteams, so our tasks include writing tutorials for outlier research teams, and we also provide support to research subteams. One example of a way in which we provide support is through our IT questions Slack channel, where people can go on it and ask questions and request tutorials that they want to see. So in order to prepare the research teams for their final reports, we prepared and led a Monday night class presentation for research subteams in order to teach them how to use Python for data analysis. And after the presentation, we gave everyone practice problems with sample data so that they could practice the skills that we taught them in the presentation.
Lastly, we encourage best practices for research reports. And we do this semester through updating the grading requirements for data analysis in reports. Now they include requiring any code relevant to data analysis to be included at the bottom of the report, and also making sure that this code is functional and well documented, well commented, to be understandable and usable by outside viewers. We've also updated the report template to have examples for doing this. So we've showed teams how to link data from the repository into the report, how to analyze data, graph it, and include those figures in the report, as well as how to provide providing good examples of code to include in the report.
Our future tasks include completing testing of the Outlier research package, writing more tutorials on using the Outlier package, Git, and Atom, and continuing to maintain the Outlier research package. If you have any questions or recommendations for us, feel free to reach out to either Hannah or myself. Our contact information is presented on the slide.
And here we provide some useful links for our Python package, which has a documentation site and a GitHub repository, and we have other links to the other resources we provided to the teams this semester. Thank you for watching.